Welcome back to the channel. So this is part 2 of my loading of hot water store on a cheaper rate overnight with a heat pump. It is an experiment. I sort of knew roughly some of the numbers that we've got on this sheet here, but I just wanted to show you potentially what we could do. So the heat pump took about 8.7 kilowatts to heat it from about 35 up to 72 degrees. That's 440 litres roughly stored, and that was my prices are down here, so I am going to put those in now, and 30p during the day. So this is my cheap rate at night that I get between 12:30 and 4:30 a.m. and this is the normal daytime tariff that I use. So to heat that 440 litres, used 8.7 kilowatts, and it cost me approximately 78 pence to charge that. If I had done the same on the higher rate, it would cost £2.61. So that is a saving, or potentially a saving, of £1.82p. So this is the heat pump side of things, so I need to crunch the numbers in. So we are using 0.9 pence and 0.3. So the store took about 2 hours and 17 minutes to heat up. It was heated from about the heating from the store. So now this is me running my heating system just from my store, not heat pump or anything else, and it ran for about 3 hours and 25 minutes. So that's pretty good. I was quite pleased with that figure. So what I did is I then ran the heat pump for approximately this amount of time, at trying to run it at about 33 degrees flow temperature from the heat pump, and in 3 hours 25 minutes it used 4.3 kilowatt hours. So at 0.09, get that figure right, 0.09. So that actually took, if it was done on the cheap rate at night time, that would be 38 pence. If it was done on the expensive daytime rate, that would be £1.29. So that's a difference of 90p there. So the figure that we're all wanting to see and know about is this one here. So the saving by charging the store on a cheaper rate at night and running the heating system compared to just running the heat pump, I'm making a whopping 50 pence per day saving on that setup. And to be fair, I wasn't expecting pounds and pounds and pounds, but in my part 1, part 2 of my revamp of my heating system, I did say that you could potentially use other means of heating the store. So one of the ideas is to use wind power, for example, onto low voltage 24 volt or 12 volt 24 volt immersion heaters. Most little wind turbines come as 12 or 24 volts quite cheaply, and in the winter is obviously the wind's quite seems to be more apparent in the winter than it does in the summer, especially the days we've been having recently. You could put solar thermal into the store, or I don't know, something else, a renewable source that you have. some spare PV panels, again, running into a 12 volt, 24 volt electrical immersion. So for my system, I could potentially wait until the store hit a certain threshold before allowing it to actually run into my heating system. But for now, we're just using the heat pump. So this is my current rate. So I pay, as I said, 30p during the day, including the peak time between 4 and 7 in the afternoon, and this is 9p between half midnight and 4:30 in the morning. So if you put it on, say you had an Octopus Cozy tariff, so we could put those numbers in. Uh, 46, and again here I'm going to do 117 and 0.46, and again it comes out roughly about 50 pence saving, which is a bit of a shame, but hey ho. So yeah, at night time, that 8.7 kilowatts would cost you £1.47 to heat up. If it's done on the expensive rate, it would be £4. And again, during the day, without the store, the same amount of energy going into the heat system would cost you approximately £2. And the last one I'm going to do is a rough sort of estimate of what it would be if you were on Octopus Agile. Now I've tried to, obviously Octopus Agile, if anybody doesn't know, is the rate changes literally every half an hour. So in the winter you can actually get, when the wind is really blowing and there's not much demand on the grid at night time, the wind turbines or the wind farms in the sea, they can overproduce electric, so the grid will actually sell it back to you, or buy it from you to use it. They will pay you to use it. So we could get down to some really silly figures, or even minus figures. So that figure there could actually be a minus. So I'm going to punch those in now as an estimate. So this is 0.02p, and a daytime, let's just use an average daytime, let's use 33p. And again on this side I'm going to do 0.02p and 0.33p. So if you were on Agile and you did have these sort of numbers, that could amount to, well, say significant saving, but it certainly could amount to a saving of £1.24 per day. So obviously over 30 days, let's put in 30 days. Let's do so that could be £40 a month. You know, if you had those, if you have that sort of times and tariffs and charges for 40 days, you could potentially save nearly £50 a month. Guys, this is just an experiment. This is, this is what I do. I like to play around with these things. I wanted to try it just to see if it was possible, and it is possible. And if you had some really good high and low, I mean, if your tariff was really expensive but your nighttime tariff was really low, you could make some savings. And obviously there's a lot of extra kit involved and room to have that plant I've got mine in my garage. The most of the equipment was used second hand already, even some of the 3-port valves. So it didn't actually cost me a lot apart from my time. And I might come up with some other ideas. But for now, that's about as much as I can tell you. So would I do it every day? Perhaps not. Could I load the store up when the weather was nice and my PV was producing a lot? Yes. Could I fit a wind turbine? Yes. But again, how much would that gain me? Could it take a week for the store to heat up on a wind turbine, to only get me 3.5 hours runtime? So yeah, a lot of figures, but I hope you enjoyed this. I hope you enjoyed this little experiment. As I said, the store isn't always part of my system. I can bring it in and bring it out when I need to under automation. So all these numbers and bits and pieces that you see here, I could actually set up in Home Assistant into an automation to only charge the store when the tariff was at a certain point or a certain threshold. My heat pump's running today. It's quite cold where we are today. It's 6.3 degrees. It's currently running at a 42-degree flow, and we're running at about 4.46 COP. So this is live data at the moment. The DT between the flow and return is about 5.6. The flow rate is 1.3 cubic meters an hour, and that is the flow that's going out to the heating system. But there is definitely a difference between these two. I think I'm trying to find a way to add some figures onto that to make it about the same as that. Right, I'm going to stop waffling on. Please comment and subscribe. I hope you enjoyed this video. If there's anything you want me to try with my setup, then please ask. I wish everybody a happy new year. So this is the first video I've done in the new year. Hope everybody had a great time, and I will catch you soon.